Alright guys, so today you should have turned in your homework already in the hotspot, graded that pretty quickly. You should have grabbed the warm-up off the table and then 2 little pieces of graph paper. We're going to use those in our notes today, and then also your calculator, journal, and your pencil pouch. Once you have all that stuff, what I want you to do is answer and fill in these boxes. The first 2 boxes says use the table below to record what is the same and what is different about the lines in graph A. Same thing, what's same and different in the lines in graph B, and then see if you can answer the communicating about math at the bottom. We'll give you a couple minutes to work on that. When everyone's ready to go, then we'll begin. So one of the first things I looked for in graph A is I know that these are linear, so it looks like all the lines are linear, so I'm going to put that down for the same. They all make straight lines. Another thing that I notice that are the same is that if I read it from left to right, what direction are these lines going? They're going down from left to right, so that means that it's a negative slope. And the distance away from all these, if I pick 2 points on each line, so for instance these 2, I'm going down 3 over 1. If I pick another point that lines up perfectly, down 3 over 1, down 3 over 1. So the slope here is down 3 over 1, so the slope here is negative 3. Now again, we're going to be working into finding the slope and finding the y-intercepts, but this again should be review. So if you didn't have these written down, go ahead and write them down now. Things that are different, okay, it looks like, well, you could put probably the parallel too. Parallel lines for the same. Now the difference between all of these is it looks like they have different y-intercepts. So if I look at this first one, the y-intercept for this first line is negative 4. The y-intercept for the next one is a positive 2. And then the last one looks like a y-intercept of a positive 8. So one thing that I can write down that are different is that they're all, the y-intercepts are all different. I think other than that, those are the big things. You might have had something else, which is awesome. But look at graph B. Okay, I'm looking for something that are the same. Well, again, I noticed that everything's linear. I also noticed that they all intersect at one point, which is here. And that's on the y-axis, so the y-intercept's all the same. Which is different than the one above, because all the y-intercepts are different. If I look at this first line, it's going down from left to right, so I know that's a negative slope. The other 2 are going up from left to right, so those are positive. However, the difference between those 2 points are a little bit different. So all the slopes are different on graph B. One's negative, 2 are positive, but the steepness of the lines are different. Not parallel here. These are the big things. So if you identified those, awesome, you're on the right track. Now if you were able to get the communicating about math, that's even better. It says describe a line, so you're going to have to make a line that could fit for both of these graphs. So, what is one thing that would fit for both graphs where they have to have the same things here? One thing that you could say is that the y-intercept, again for graph B, all the y-intercepts here were 5. So your line would have to have the y-intercept of 5. It would have to be a linear graph, making a straight line. And it has to have a slope that's negative and negative 3. That would match The slope part matches the first graph, graph A, because every single slope is -3, and then the y-intercept matches graph B. So who can write an equation for that? A linear equation, so it checks off that one. That has a y-intercept of 5 and a slope of -3. See if you can go ahead and write an equation for a line that matches all of this criteria. Okay, you should have came up with, again, y equals mx plus b, because that's a linear equation. The y and the x don't change. What was the slope here? Slope's -3, so that's going to go in front of the x. And the b would represent our y-intercept of a +5. So I'm going to go ahead and put +5 as well for the slope. So if you had this equation where it was y is equal to -3x plus 5, you would have got that correct. This is a line that would satisfy both graph A and B. So the last 2 days we've talked about whether it's a function or not, and if it's linear or not. So instead of identifying if it's a function or not, today we're going to be graphing functions. And graphing from an equation or some other type of word problem, we're going to graph it to find some results. So go ahead, and the next page in your journal, go ahead and label that 2-4 graphing function rules. Today is September 23rd. Go ahead and head that as well as the page number in the top right corner and fill out your table of contents. So this is page 41 for me, and we are graphing function rules today. 2-4. Okay, so before we begin, we have to make sure we understand the function that we're talking about. We're talking about linear functions here. So we talked about this yesterday, but all linear functions so far that we know are in this form, y equals mx plus b. Let's go ahead and go over what these letters represent. So if I want to identify what the m is, you should know that that is the slope or the constant rate of change. Remember, we know that it could be positive slope, negative slope, a zero slope, which is a horizontal line, or it could be an undefined slope, which is a vertical line. The b represents our y-intercept, and we might see it as our starting point. Same thing, it's where it crosses over the x-axis. The x and the y don't change, but we know that the x variables could also be identified as the domains. We're going to use the word input a lot today, and our independent variables. And then the y values, again, don't change. We know these as our ranges already. We're going to use the word output a lot today. And these are our dependent variables. Now remember, all of these equations are linear functions. We're focusing on linear right now. So, if we know that the equation, we know the parts of the equation, the m and the b, we need to be able to graph those and transfer those from the equation to the actual graph. What you're going to be given is this half paper, and we're going to give you about 5 to 7 minutes. And I don't want you to glue this in quite yet, but I want you to use the terms in the box to identify where they are located on this graph. Okay, and then we're going to define these off to the side. So take just 3-4 minutes, maybe a couple more minutes if we need it. Use these terms in the box to label all the boxes around on where they are pointing. Alright, let's go ahead and start off with the easy ones. The first thing being the x-axis. We all know where that is. Okay, the x-axis runs horizontally from left to right, so your number 8 should be the x-axis. And I'm going to go ahead and cross that off. Okay, and I want you to define it as we're discussing. The x-axis is our horizontal axis that runs left to right. The next thing that we can identify is the y-axis. If this represents the x-axis that runs horizontally, the y-axis runs vertically. So go ahead and label box 5 as the y-axis, and this is going to be our vertical axis. The next thing to define is the x or the y-intercept. Okay, now it sounds exactly like what it is. Okay, if the y-axis is the thing that runs vertically, where is the line or the point where the function crosses or intercepts the y-axis? So in that case, I'm looking. This point right here is the point where the function crosses over the y-axis. So that would be considered our y-intercept. Okay, so box number 4 is the y-intercept. And just to define that, it's the point that crosses the y-axis of the function. Now if you think about the next one, x-intercept, okay, the y-intercept is where it crosses the y-axis. The x-intercept sounds exactly the same way. If I look at that x-axis, the function crosses over the x-axis at this point, and this point actually has 2 arrows coming from it. So we're going to actually label this as the x-intercept, but it could be called something else that means the same thing. So we're just going to leave that one blank and see what we're left over with. Okay, and the x-intercept here, defining it, would be the point that crosses the x-axis of the function. Now the next one, zeros of a function. That, if you think about what's left over, I know what all the other boxes are because that's similar to rise over run and slope and figuring out the constant rate between the 2 points. So zeros of a function is actually the same thing as our x-intercept. These are called the zeros, and you're going to hear that a lot when it comes to quadratic functions. But zeros and x-intercepts are the same thing, and this is why. Let's write down, these are the x-intercepts. If I actually wrote down the point of our x-intercept, this point is 0, I'm sorry, no it's not, it's -1, 0. Okay, the zeros represent when the y is 0, that's your x-intercept. Okay, so our zeros of the function would always have the y value of being 0. X-intercepts are the zeros. So let's see what else I have left over. I have rise, run, and slope left over. So, I know rise means I'm going up or down, because if I rise out of bed, I'm going up. Run means I'm running left to right. So if I'm looking at what's left over, it looks like the rise here would be going up or down. So this part of the triangle would be considered the rise. This part right here represents the run. Okay, and we use rise and run to find the slope. Rise over run, and that should be a review from last year. Rise over run is the slope, and we always want to talk about the change of y's, because again, y values go up and down, so the change in the y, which is the rise, over the change in the x. You could see that little icon as well. And then overall, what the rise over run finds is the slope. So that's where the slope comes from. We always want to do rise over run to find the slope when it comes to looking at a graph. So everything should be labeled. What I want you to do is go ahead, and this might not fold, or it might not glue in all the way, so I'm going to fold it in half. And go ahead and glue at least the bottom half in so you have this available for you, all the parts of the graph. You could expect a quiz coming up on the parts. Biggest thing is remember that the x-intercepts are called the zeros of a function. And we're actually going to write that down at the bottom because we should have some room left over. So I'm going to put a triple star here. This is something you need to remember after you glue that in. That the zeros of a function are the x-intercepts. And go ahead and highlight that as well. That's probably the only thing that you don't know quite yet from what we just filled out. Everything else should be a review of x-axis, y-axis, y-intercept, rise over run, slope. The only thing that should be new are the x-intercepts, or the zeros, and those mean the same exact thing. Okay, so let's move on to graphing these function rules. Now what you're going to be given is the actual equation, or the function rule. The equation and function rule is the same exact thing. So say that they give you the function rule, that's y is equal to negative 2x plus 1. This is our equation, or our function rule. Now we want to be able to graph this, and we're not going to use our calculators quite yet. We're going to use our calculators to check. We need to make sure we know how to do it by hand before we actually graph it with the calculator. So what I want you to do is make this chart that looks like mine. We're going to have an x column. We're going to write the function rule, so negative 2x plus 1, and we're going to have the y column. Now to figure this out by hand, what we're going to do is use x values, random ones we're going to pick, input, remember our x's are called the inputs, input or plug them into the function, and see what our outcome is to get the points. So let's just pick these inputs, 0, 1, or sorry, negative 1, 0, 1, and 2. We'll just use 4. You can pick whatever inputs you want. So we just have to have a good graph. So what I'm going to do is I'm going to take these x's, our domains, our inputs, input them into our equation. Now remember, whenever we substitute any number into our equation, we have to put parentheses around it. So now from here I'm going to solve. If I input negative 1, I have to solve this using gems. So negative 2 times negative 1 is a positive 2, plus 1 is a positive 3. So when I plug in negative 1 into the function, I get 3 as my answer, which means when x is negative 1, the y value is 3. That's a point on this graph, or that works with this function. Let's do another one together, and I want you to finish it up by yourself. So if I plug in 0 into the function, I want to see what my output is. Input, negative 2 times 0 is 0, plus 1 is a positive 1. My order pair is 0, 1. Go ahead and do the next two, and then look up here when you're done. So as you're finishing up, look up here when you're finished. I just inputted the x values we chose to get the output, and these are my points I have. So let's look at this. Is it a function, first of all? So to determine if it's a function or not, we're looking at the x's, and we chose all different x's, so we know it's a function. And now we're going to try to figure out if it's linear or not. Now we could figure out this by using the carets, or we're going to graph it. So what I want you to do next is take one of those graph papers that you got as a warm-up, and we're going to glue that in. And I want you to make an x and a y axis on the graph. So it looks like this. And then the next step is let's figure out if this is linear or not. We know it's a function, but what type of function is it? So I'm going to go ahead and plot the points that I just found. So the first point that I have is -1, 3. So again, this is our x, and this is our y. So on the x-axis, I'm going over to -1, and then I'm going up 3. 1, 2, 3. This is the first point. Second point, x-axis is 0. Then I'm going up 1. It's my y-intercept right there. Next point is over to the +1 on the x. Then I'm going down -1. And then over 2 on the x-axis, down -3. And plotting that point. Now if I connect these points, that looks linear. So this would be considered a linear function. Again, and we're just graphing it. From the rule, we graphed it. Now another thing, now that we have our calculators available for us this year, is let's actually plug this in to double check our work. So let's go back to our calculator. And we're going to go ahead and plug in our function rule. So go to your y equals, clear whatever you have, and let's type in -2x + 1. Now remember, when we type in -2x, we have to use this bottom button. -2. The x is right next to that green alpha button. And I'm going to put +1. Make sure yours looks like mine. Now we're going to graph it. So it should look similar to what we graphed. And it does. So now let's check our table to see if these points actually match up with the points that we found. How do you think we go and find if these points are on this graph? Okay, notice the blue parts, the blue words at the top where it says stat plot, table set, format, calc, and table. We want to go to that table. So push the blue button, second, and then if I push that graph button, it will take me to the table because the table's in blue. So now if I look at my points, I'm going to move my arrow up 1. It's saying that when x is -1, the y value is 3, and that's what we found when we plugged it in, -1, 3. The next one, 0, 1. The next one, 1, -1. Next one is 2, -3. So all these points are on this function, which I know I did that correctly. So that's just another way of checking with your calculator. Okay, let's try another function rule. So I want you to do the same thing. This function rule is this: y is equal to negative the absolute value of x minus 4. So we're not going to use our calculator because you don't know how to enter an absolute value, but you can in your calculator. So put your calculators down, and again I want us to use our xy table with the x on the left, the function in the middle, which is the process, and then our y. Again, we're just going to pick -1, 0, 1, and 2. And I want you to go ahead and work with your neighbor on this. I want you to set up the process, figure out the output, write down what our points are, and then by using that second graph paper, I want you to graph what you think this function looks like. So I'll give you a couple minutes to work with your neighbor on this, and then when you're done, we'll push play and begin. Now that you've had time to work with your partner on this, let's start. So again, if the input is -1, I'm going to plug in, again with the parentheses, -1 inside of the absolute value bars. Now remember, the absolute value bars represents the distance away from 0. And it always comes out positive. Remember, we talked about jail. When you go in, you might not be a good person, but when you always come out, you should be a better person. So -1, distance away from 0 is a +1. This negative ends up making that +1 and -1. -1 minus 4 is -5. So this point should be -1, comma, -5. Okay, the next one I plug in 0. Absolute value of 0 is 0. -0 is really not possible. So I'm left over with -4. And this point is 0, comma, -4. If I plug in a +1, absolute value of +1 is a +1. The negative makes it a -1. Minus 4 is -5. So this would be 1, comma, -5. And then the last one is I plug in 2 to the absolute value bar. Distance away 2 is from 0 is 2. That negative in front makes it a -2. -2 minus 4 is -6. So this is what the inputs and outputs should be for this function. Now we have to determine if it's a linear function or not. So first of all, is it a function? Yes, it is, because all the x's are different, so it is a function. Now we have to determine if it's linear or not. So on my graph, I'm going to go ahead and plot these points. So -1, -5. I'm going to go over -1, down 5. 1, 2, 3, 4, 5. And put a point there. Next one is 0, -4. So 0, down 4, 1, 2, 3, 4. Next one, 1, -5, over 1, down -5. And 2, -6, over 2, down 6. Now, if I connect those, it makes a graph that looks like this. Is that linear? No, it's not, because remember, it changes direction, so this would not be considered linear. Okay, so again, we use that function rule to input the x values to get the output, which are our y values. Okay, and the last thing we're going to do is looking at some real-world problems and identifying some things. So the next thing you're going to get is this half sheet. You don't have to glue it in quite yet. So when you get this, we'll pause it until everyone's ready. So for this first question, it says the function rule W equals 8g plus 700 represents the total weight W in pounds of a spa that contains g gallons of water. So they use different variables, W and G, instead of the X and the Y, but that's okay because I identified it for you. The question's asking, what is the total weight in pounds given that the capacity of the spa is 150 gallons? So they say, okay, if this is 150 gallons, what is the total weight? Now let's identify the letters, okay? First of our total weight. Which one of these represents the weight? Okay, remember it says weight is W. So we want to figure out what the total weight is W when gallons, which is the G, is 150. So go ahead and label all that information. Now, one way of doing this is just to plug in what we know. If I know that the gallons is 150, what would be that total weight. So here's my equation. W is equal to 8G plus 700. And I'm going to insert 150, which is my input, which is the G, in this case the X value. I'm going to plug it in for the G in my function rule. So W is equal to 8 times 150 plus 700. And now I just solve from here. So I have to multiply first 8 times 150. I'm going to use my calculator. 8 times 150 is 1200 plus 700, which will give me that the weight, the total weight in pounds, whoops, so it's 1200 plus 700, so this should be 1900 pounds. So again, they're going to give us the X value or the Y value. We just have to input it in to solve for what they want. Now this second question is working backwards. Go ahead and take a second to see if you and your partner can figure that out. So we'll pause the video until everyone's quite finished. The second one is, what is the weight of the spa when it's empty? So again, if they're asking me this question, the weight, that's what they want me to find. What's the total weight when the spa is empty? How would I identify the spa is empty at this point right here? Okay, the spa empty would mean that there's no water in the spa. So the gallons of water would have to be 0 here. So again, we still have this spa. We want to figure out what it is when there's no water in it. So again, I'm going to use my function rule. W is equal to 8G plus 700. And we want to know when there's no water in it, so the gallons is 0, how much is it going to weigh? So again, 8 times 0 here is 0. And we have the y-intercept, which is 700 pounds. So remember we talked about the y-intercept is also called the starting point. Okay, we start off with it already being 700 pounds with all the materials that it's made with. Everything is 700 pounds. When there's no water in it, because it's totally empty, it's just going to be the y-intercept, which will be that 700 pounds. That's the starting point. Okay, so I'm going to go ahead and write y-intercept here. So that's sort of a real-world situation and how we incorporate that function rule with our inputs and outputs. So let's take a second to go ahead and glue this in. I'm again going to fold mine up so it fits. And I'm going to glue that in. So I have that available for when I look back in my notes on Monday. Alright, and that's it for today. On Monday, when we get back, we're going to be actually writing the function rule. So I might give you the graph, and you have to figure out what the function rule is from the graph, or what the equation is from the graph. Okay, so make sure you're ready to go on Monday, and we will see you then. Have a great weekend.